Hello and welcome everyone. Thank you for joining us today for our webinar called Maximizing the Impact of Machine Learning through Model Ops. My name is Ivan Trehin and I am on the marketing team here at H2O.ai. And I would love to start off by introducing our speaker today. John Spooner is EMEA Head of Artificial Intelligence at H2O.ai. And before I hand it over to John, I would like to go over the following housekeeping items. Feel free to send your questions using the questions tab. John will try and answer them at the end of the session. And this webinar is being recorded. A copy of the recording will be available after the presentation is over. And now I'd like to hand it over to John.
Thanks, Ivan. Machine learning and the models created by this process offer no value whatsoever to business. Nothing, zero, in fact, diddly squat, unless the following happens. Those models that are produced really need to see the light of day and be used in a production environment that allows a process to automate some sort of business decision, whether that be predicting which part is going to fail in a manufacturing process, whether it be maybe the next best action to make to a particular customer, or whether or not we want to forecast demand in the next hour. There has to be no delay whatsoever, or as little as possible, between an accurate model being built and that model being deployed. All the models that are then in production need to be constantly generating high levels of accuracy and benefit, underpinned by a full audit trail of how those models were built and deployed. This webinar over the next 20 to 25 minutes will help you understand how to maximize the impact of machine learning through model ops. My name is John Spooner, and let me quickly introduce myself to you in the form of some numbers. How else would someone do this who has a degree in applied statistics and has been working in this AI industry for 23 years? It's amazing that I've been in the industry for so long, considering how young I look. I've worked with many companies on their AI strategy over the last couple of decades, whether it was a large global financial organization who want to automate their credit decisioning using tens of models, the major telecommunication company who wanted to speed up the time of getting their hundreds of cross-sell models into production, or the financial services company who wanted an end-to-end audit trail of their machine learning models that predicted which customers to churn. I've built up a huge amount of experience of where the challenges in this end-to-end process lies and what teams should really do to avoid the mistakes that many, I still feel, are making. And I'd like to share with you some of my thoughts on this particular subject. Currently, I have the pleasure of being employed by the #1 open software company in the world, where we focus on artificial intelligence and machine learning. Through automation, we are allowing our customers here at H2O to build hundreds, thousands, and millions of machine learning models, making data scientists so more efficient and valuable. The structure of the webinar will be as follows. First of all, I'm going to talk about the challenges around machine learning productionization. Then I'm going to introduce you into the concept of model ops. Then I'll talk to you about how H2O can help on your journey. And then finally, it will be your turn, where we will hand it over to yourselves, where you can ask some questions and answers. If you do have any questions during the webinar, do feel free to put that in the questions tab and the chat tab, and I'll constantly be reviewing those and weaving those hopefully into the presentation as we go through this. So, artificial intelligence, as we've really known, has evolved significantly over the last few years, from being really a technology buzzword to the commercial reality that it is today. We can see that the technology is having a massive impact across many industries, changing the business landscape. If we look at this particular equation, for years we have heard that data underpins this evolution, and organizations have spent millions on their data platforms and their big data solutions. However, that data is of little or no value if it can't be utilized without limits on scale, performance, or flexibility. The real key to gain value from this data is to start embedding machine learning technology into business processes identified by people and people working with technology to help companies really gain this massive value. And the speed at which you get this transformation will give you, as an organization, competitive advantage. But this process isn't magic. So what are the high-level steps that any project goes through that has machine learning embedded within it? At a really high level, this is the end-to-end process, and it's 5 key steps: defining the problem and how we're going to solve that particular problem, acquiring and working out which data we're going to utilize and preparing it so it's ready for machine learning purposes, going through the building of the machine learning model and its various steps. Once that model has been built, finalizing that model and making sure that it's fit for deployment, and then putting that model into a deployment environment and monitoring its performance. And as that model then degrades, starting that process again. The key thing, though, is the speed at which you go through this particular cycle. So many organizations are spending weeks, months, and maybe years just going through one iteration of this particular cycle. And it's the speed at which your teams move through this cycle which will allow you to stay ahead of your competition. We need to start to bring together the gaps in this particular process, and automation lies at the heart of speeding up this process. What I'm going to do today is really focus on the left-hand side of this particular wheel, the model finalization and the model execution. And the reason for that is, to be honest, over the last 10 years, we've seen this process being executed, but the challenge that organizations have had of getting to that finish line of having a model in production is the bottlenecks that occur within that process. If I look back 5 to 10 years, the big bottleneck in this process was getting data. And as organizations collected more and more data at a lower level of granularity, the bottleneck of getting insight was just acquiring and getting all the data into a format and a platform for it to be utilized. We've removed that bottleneck using big data solutions, whether it be Hadoop infrastructures on premise or using cloud native data warehousing platforms. And what this has enabled us to do is to move the bottleneck now into the machine learning build phase, where organizations are now able to build or look to want to build many hundreds and thousands of machine learning models because they have the data available and the business challenges to do that. Through AutoML tools, we're solving that particular problem of the number of models and the delay and the bottleneck of building models. But all we're doing now is shifting the bottleneck. If data scientists are producing millions of models, they still need to be finalized and put into a production environment. And this is where I really see the big challenge being. And the benefit that organizations have is if they can decrease the time that it takes to move through that, that's where you get competitive advantage. If we look at some statistics in terms of the current state, this is really where we are. There are loads and loads of models being built by data scientists and citizen data scientists using machine learning technology, but few of these models are being deployed and used in production applications. Quoting Gartner, they say only 47% of models designed for production are sustainably deployed. So the majority of models are not being deployed. That's tragic. But why is this the case? Well, in my view, and working with organizations, there's basically a breakdown in the system. At the end of the day, when we look at this process, there are two key actors involved: data scientists and IT. Data scientists are meant to be there to create the machine learning models and then look to production IT to deploy and manage them. But in my view, these players are not living in perfect harmony, and that's what's causing the majority of these machine learning models to be undeployed. But what's causing this rift between data scientists and IT? I really see this across 4 dimensions. The first one is they have a different mindset. That's not a bad thing at all. If I think about my wife and I, we really do have different mindsets about so many different things, but we can work in harmony. Well, most of the time anyway. Data scientists tend to be creative and experimental. They don't like process and are very focused on building the best possible model, usually measured by being the most accurate, using whatever tool or technology that they like. IT, however, like to make things work. They like to make sure that the IT systems are up and running 24/7. They like things to conform to standards and processes because they are accountable for the systems that are making the decisions. These two mindsets seem to be at odds at each other, and there needs to be something that fills that gap. Data scientists and IT also have very different competencies. Data science teams don't know or necessarily care or really should care about production environments and code requirements. IT teams don't know how a machine learning model gets built and probably shouldn't do. They don't really know what a gradient boosting model is or what machine languages like Python or R, what they are, or what even a machine learning library is. If I also look at the size of the teams, the data science teams are under more and more demand from many parts of an organization to solve specific business problems because everyone wants to have AI underpinning their processes. But they, like every team, are constrained by resource. There's a big drain on data science talent. And it's not wise for them as we increase the number of models that they're producing. It's just not wise and cost effective for them to increase their competency around IT systems, where we have perfectly competent teams in IT who understand all of those. However, what we want to do is avoid that notion of, well, let's throw the model over the wall to IT and they will sort it out. Because IT will just end up saying, well, what is this machine learning model thing and what is it? Really, if they've got that attitude, then that model is dead on arrival. And then finally, there's a lack of ownership of the problem. The data scientist thinks it's IT's problem to deploy a model. IT go, well, if you had given me something decent, I would deploy it a lot quicker. Actually, the key teams that are losing out are the business, whether that be the marketing team or the fraud team or the risk team or the production team that are not able to gain true advantages from machine learning because of the delay or non-existence of models in deployment. So what does success look like today? So many data scientists just concentrate on the machine learning code. However, to be totally honest with you, that's only a tiny part of the success of a machine learning project. This paper that's documented in the bottom left-hand corner really highlights the larger problem really well. Projects where models are successfully deployed in production today require intense effort on the part of those data scientists and IT ops to work together. Because of the deficiencies of each party that I've spoken about, IT ops has to get involved in the recoding of the productionization of these models to ensure quality to be run in operational scenarios. That's prone to error and require loads of checks and balances to make sure that's correct. Data scientists have to get involved in the production side to troubleshoot implementations and make sure their models are working properly. This world in so many companies is so manual, with loads of custom code flying around the model. The problem with this is this code tends to be really brittle. And when things go wrong, which, let's face it, they always do, and that model is going wrong in production, there's a mad scramble to fix it that pulls the data science team and IT ops teams off other projects. Models in this environment also have limited monitoring capability. The type of monitoring at the moment is more akin to software monitoring, such as how much memory is being used by that particular model, what's the response time of that model, and the like. Don't get me wrong, this is necessary, but there's it's insufficient to really know that information, because what you want to know is whether or not the machine learning model is behaving properly. We need to know if the model is producing predictions and forecasts at the same level of accuracy of when the model was built. Just like a fish, a model goes off, and we need to know when, and we need to know why. These current tools that we have in place do not warn the user at all about the machine learning specific issues. The solution is as follows. 1, you do nothing and hope the model is still good. Or 2, you refit that model on newer data and redeploy models frequently to avoid possible degradation. Neither of these is ideal. Do you want to run your business hoping the model is okay, or do you want to utilize expensive compute when you don't need to? So I pause here for a minute because I also want to highlight another point. It's not particularly sexy and it's rather boring, but to be honest, it is fairly important. Once more models are put into production, they become part of the mission-critical machinery organization. This is a whole new level that requires careful consideration of how these new assets should be managed and governed. In particular, there's 4 key points here. First of all, who will have access to production models? How will you limit access to only the people that need it? How will you track access for troubleshooting and compliance reporting, if necessary? Secondly, change tracking. Not only do you need to track who can make changes or who are making changes of these machine learning models, but you need to track when those changes were made. All of this has to be logged for compliance and also for troubleshooting purposes. Your model assets and even the data used to train them will need to be maintained for legal and regulatory compliance. For example, if your business is sued for racial bias, you will have to go back to show the model that was used, what data was used to train it, to make your case that at that point in time, your model was not discriminatory and it was not biased. Without these assets in place, it will make it incredibly difficult to make your case. Hopefully though, I think you get the picture. Whatever you do, as you scale this process, you will need to make sure you have the right controls in place and capture the right kinds of data and artifacts to ensure you're meeting both legal and any regulatory standards that are specific for your industry. So, what is that solution, that magic bullet, to gain the most value from your machine learning models? Well, that solution is model ops. So welcome to Model Ops, also sometimes known as ML Ops. And basically it's a new technology, a set of practices that allow you to scale and govern your machine learning projects in production environments. It allows your data science and IT teams to work in harmony, to collaborate on AI projects, such that your IT operations team, now maybe rebadged and resold as your Model Ops team, can now manage many of the common operations needed to keep your models healthy and up and running in production. The only time that your data science team should or even need to get involved is when there is a serious issue with a model. This gets your data science team back doing the job that they love doing and they're paid to do, which is building more and more models. And it allows your model ops team to spend the time on the task that they're good at, which is deploying and managing models, which gets you to the operation that will scale to meet your business needs. IT teams are used to creating new versions of software components that are being developed, where the release candidate gets promoted through a series of staging areas. Such progression usually includes the need to pass automated unit tests, integrated tests, some form of manual testing, performance testing, and eventually acceptance user testing. There is no reason whatsoever to treat machine learning models any differently. So, what are the key components of Model Ops? Really, it has three legs. First of all, you have production model deployment. This is all about getting the models up and running on production infrastructure where they can be served to a decisioning environment. Whether that be a model that's being used in a real-time response, whether it be a model being used in a streaming use case, or whether it be a model being served up to do batch processing at the end of every hour or the end of every day. Production model deployment is about getting those models up and running. Once you have those models up and running, the second pillar here is model lifecycle management. Within this stage, you need to know if your model is performing as expected. You need to troubleshoot production issues. And then when the time is right, you need to update those models. And then finally, you've got production model governance. This is all about maintaining control of production models, making sure that those models are safe, making sure that you have all the information required and documented for any legal or regulatory challenge. So let's take a look at each of these three components in more detail. So let's first of all look at production model deployment and the three rules that I see that you should look at when looking at this whole area. So rule number one, make sure that you use technology that makes it easy to scale. Model Ops makes it easy to get your scoring pipeline up and running on production infrastructure. Make sure that you're using technology that allows you to do this quickly, such as Kubernetes. Kubernetes is ideal because it easily scales up and down as you need more or less capacity based on the use case that you're dealing with, whether it be, as I've said before, real-time streaming or batch. Kubernetes is also great because it has built-in redundancy and failover mechanisms to make your production models far more robust. Secondly, make machine learning models immediately visible to deployment teams. Here at H2O, what we're seeing is data science projects being made immediately available to model ops environments. So that model ops engineer can select the desired model and start to move it quickly into production. If there's any lag or in this process, you'll just add in another bottleneck into the process. But you also want to consider bringing in open source models as well that can be quickly imported and then deployed. And the key is that you are removing the error-prone and time-consuming process of recoding that is still common in some companies. The key is build a model, throw it over the wall to IT, but in a format that IT don't have to think about the model itself, but more about how do we then quickly deploy it into our environment. And that leads us on to rule number 3. Really allow for a dev, test, and prod approach. By providing the ability of using this approach, IT teams can deploy to a test production environment to make sure it performs as expected. But why is this critical? Well, it's because the model ops engineer won't be looking or worrying about the code of that machine learning model, but they're focusing on the behavior of that model. Is the model accuracy still as high, as well as the speed of generating that prediction? Does it have the ability to cope with the expected data throughput every minute or every hour or every second? If so, and all those checks are green, then that model can be promoted to production and it becomes available for all production requests. If the model ops teams then have questions about the model behavior, they can then start to bring the data scientist team in to shoot those more in-depth questions. But they'll have created a framework that now allows the data scientist to see exactly which model is currently in production and what tests have already been made. So now that model is up and running, it really begins a whole life cycle in itself in production. That process is referred to as model lifecycle management. We need to make sure that when that model is up and running in production, it's staying healthy and continuing to provide accurate results. When any update is needed due to maybe a time constraint that we put on models that they should only be in production for a certain amount of time, or it's starting to degrade, we want to make sure that the process of updating is seamless and that the new model that you put in is better, not worse. So what needs to happen? Well, first of all, monitoring. We've already talked about why simple software monitoring is just not sufficient for machine learning models. If you think about it, models are created from data and algorithms, or sometimes, as I refer to it, at the end of the day, it's just a model based on data and some clever maths. When the data we see in production is different from the data we trained our model or built our model on, that model will not generally produce good results and therefore can be unreliable. So what we need is a set of tools designed for machine learning specifically. One such tool is drift monitoring. Using this technique, we compare the features of the training data to the features of the production data. When we see a significant deviation, we can show that in a dashboard or alert the operator to the issue, as this is one indication that our models are going bad. This is important specifically for use cases when the known outcome may not be known for weeks or even years, such as credit risk. Knowing if a customer defaulted on a loan, we won't know that truly for many periods ahead. Second point is alerting, and this is a really important part of model ops. As you scale the number of models you have in production to thousands to millions, it will become impossible to see what is going on with all of them. You need to start to manage by exception. To manage by exception, you need to set up guardrails around your models and have system alerts to spot when those boundaries are crossed. You need to make sure that you have an environment that's flexible when it comes to alerts and push those alerts through a variety of systems, including email, text, Slack, PagerDuty, or many more. Ideally, what you should be doing is having a flexible environment that allows you to set up alerts to trigger whatever system is best for your business. And alerts should be proportional to the level of the issue. What you don't want to have is lots and lots of false alerts, because then people would just ignore them. So make sure you split your alerts up. So maybe have low-level alerts for maybe non-critical models sent via email to a project team, or maybe put into a team Slack channel. But where you have more critical models, maybe route those alerts into incident response systems such as PagerDuty. Third point, failover and fallback. When models fail in production, and trust me, they will, because I've seen it happen, what do? Well, you won't have time to fix the model right there and then. So you need a way to fail gracefully, to then give your team time to troubleshoot and recover whatever was wrong with that particular model. Make sure that within your model ops environment, you've got rules in place that then switch to maybe a secondary model. This allows your system to continue to respond to requests with reasonable answers while your team is fixing the issues behind the scenes and getting your primary model back into production. Fourthly, what do you do with regards to updates and when your model is starting to degrade in production? You need to make sure you update that model on the live system, but you can't degrade the experience of users and apps. You can't say, oh, please hold the line caller, our machine learning model is just being updated. So this means a couple of things. First, you need to make sure that the version you are introducing is fully tested prior to swapping it for the current version. But also, secondly, it means that you need the means to switch the model without disrupting responses. There's a number of different ways to go around this. Model testing and warm-up processes, maybe using blue-green and canary deployment accomplish these. And these are standard features in model ops software. And then finally, split testing. When you introduce a new model to replace an older one, you will want to test the new model under real-world conditions. This usually means running a test where the new model sees some percentage of requests and response going through it to enable you and your teams to see how effective it is. And this is especially true if you want to assess accuracy or effectiveness based on how people behave. And then finally, production model governance. Governance, as I've said, isn't the most sexy subject, and isn't the first thing that people think around when productionizing models, but it probably should be. Without strong governance practices, it's really impossible to scale models in production environments. So how can model ops help here? Well, really, I see it in 4 areas. First of all, you've got the access control, making sure that we have strong processes and policies in place embedded into software on who can update them and change production runtime parameters. Make sure that any model ops system handles this well and integrates with your directory system and role-based access control to limit access to only those who need it. Does every person need to have the mechanism to promote a model into production? Secondly, make sure you're tracking all access requests and any changes that are made. Logs of who has access and what they changed are critical for legal and regulatory compliance, not to mention, as we said before, troubleshooting when issues arrive. Third, make sure Model Ops has version control that makes sure you include all the prior versions of the model, and ideally the training data, or at least the metadata about the training data set. Make sure you have documentation on who built the model, when they built the model, how that model was built, who signed that model off, and how is that model making decisions. Knowing which model was being used at which time is crucial for when the regulators come knocking on your door, especially when consumers start to question, how was that decision about my loan application made? Or why did you flag my fraud transaction for the 10th time as, why did you flag my transaction as fraudulent for the 10th time this month? Or why have you given me this particular price for my car insurance? This versioning system allows the user to roll back to a prior version of the model if needed, if it's going out of kilter. So we've talked about what Model Ops is, but so what? What's the impact of that? What's the value that it can provide? Well, first of all, it really drives collaboration and automation. Model Ops allows your data science and IT teams to collaborate to deploy and manage models in production, allowing your resources to be used far more effectively in a far more cost-efficient manner because you're automating so many of parts of the process and therefore saving costs. You're also maintaining control over models and production environments. This is allowing you to minimize risk, including accidental changes to production models, and giving you all the data you need in case something does happen and you need to provide information, keeping you out of jail. And then finally, you've now got a platform to scale. As you build and deploy more and more machine learning models to solve more business problems, you don't have to scale this up by adding a ton of people. You've now got the technology guardrails and alerts to really focus efforts of your operations on areas that need attention rather than just business as usual. This allows you to be more cost effective, solve more problems with exactly the same resource, allowing you to increase profit. So, how does this then all relate to technology? Well, the key is making sure that you start to join the actors together, whether it be joining the data scientists, building those models, the people deploying those models, or those end consumers that are acting upon those results from those models. As we start to democratize AI, you need a platform to join those components together. And that's where the technology from H2O can help you do that. The technology that helps you do that from a deployment perspective is called Model Ops. And this allows you to deploy your models, manage your models, monitor your models in a governed framework, ticking off all the points that I've talked about in this particular webinar. But what we also have are various components that allow you to automate far more of the machine learning process than just the Model Ops. You've also got technology that is highly scalable and automated that allows you to build the most accurate model on the planet. We can quickly deploy those and make that insight available to end users using our platform called Q. But it's not just about technology, it's also about who's using that technology. And we're providing software that can be used by your organization. But as part of your investment within H2O technology, you get access to our people. Over 10% of the smartest brains on the planet of Kaggle Grandmasters work for H2O, and they are all part of the package when you utilize H2O technology. We've got hundreds of customers and hundreds of stories that allow you to see where AI really makes a big difference, whether it be in credit underwriting, saving millions of pounds through efficiency gains, or whether it be through optimizing the speed of which it takes to build models. We've got large amount of case studies that show you the value of utilizing our technology and people. So, to summarize, model ops is critical to make sure that your company gains the most from machine learning as part of its AI transformation. As enterprises look to make their own AI with your own data, a new set of challenges have emerged, and model ops is the solution to them. Make sure that you're maintaining reproducibility, traceability, and verifying these models. Make sure that you're recording experiments, tracking these insights, and reproducing results. Make sure that your teams are collaborating to create real model factories for enterprise data science efforts. Data and model lineage, making sure that you're addressing regulatory compliance. We here at H2O are here for you, providing you the best machine learning technology, as well as the people and the experts to help you succeed, to make sure that you get that whole transformation. Okay, thank you all very much for listening. If you do have any questions, feel free to write those in the chat or within the question tab. So I do have a couple of questions coming in, so let me just have a look at those. So the first one is, what are the metrics that we should be measuring to help us see if we have a good ML ops strategy? That's a really good question. I think one of the metrics should be, have a look to see how many models do you currently have in production. The more models that you have in production, then the more success that you're gaining with machine learning. But also look about the speed at which it's taking to get those models into production. Have you looked at how long it takes from that problem identification all the way through to model deployment, and look to measure how long that takes? Also look to measure how big your teams are. You should be scaling your models at a far greater rate than the number of people that are underpinning that particular strategy. Okay, another question that's come in is, we're working on several machine learning projects. What sets H2O apart? So really, I would see that as a number of things that set ourselves apart. One thing that I've already talked about is the people. We've got the best expert, we've got the best machine learning people on the planet that can really craft how to solve a particular machine learning problem for your company. But secondly, it's the technology. The technology will enable you to build the most accurate model in the shortest amount of time. It will enable you to put all the checks and balances from a governance perspective. And because it's all built on one platform, the speed at which you go through that process is a lot faster than having to build it from scratch. So that's the key thing that really sets us apart, the ability to build highly accurate models, ones that are flexible, and ones that are highly governed. And then one more question here. I'm only producing one model a month. At which point does it make sense to embark on a model ops journey? Well, some people think that maybe putting all this governance and structure around just one model seems to be a lot of effort. But what it does is to allow you to create a great foundation. So even if you're only producing one model a month, that's 12 models a year and 120 models over a decade. And that won't be the limit. You will increase the amount of models that you have. So I would say any organization that is producing models need to start to embark on a model ops journey. And the sooner that they do it, the greater the benefit will be. Okay, so we're just coming to 11:15. Just have a quick check. Are there any more questions from anyone? Okay, so all that's left for me to say is thank you very much for your time. My name was John Spooner. Feel free to contact me over LinkedIn, or if you want more information about H2O technology, feel free to go to our website at www.h2o.ai. Thank you for your time and have a lovely rest of Tuesday. Take care. Bye.
Thank you, John, for taking the time and doing a great presentation. And thank you to everyone who joined us today. We hope you enjoyed this session. We have many other online events planned, so stay tuned and have a great day. Thanks, everyone. Bye.